Okay, welcome back to E to Z Pre-Algebra by Carol Lorandini and presented by Barron's, right? Chapter 15. As you can remember, I started these videos at chapter 14 because I had already done most of the book before I started this channel. But chapter 15, the Pythagorean Theorem, and there's a few things we have to know before we dive deep into the Pythagorean Theorem. One of those things is, what is a mathematical proof? So that is an inferential, so we're making an inference, right? Argument for a mathematical statement showing that the stated assumptions logically guarantee the conclusion. The argument may use other previously established statements such as theorems, but every proof can be constructed using only certain basic or original assumptions known as axioms, along with accepted rules of inference. The philosophy of mathematics is concerned with the role of language and logic in proofs in mathematics as a language. So we need to know what a theorem is, the Pythagorean theorem, right? A theorem is a result that has been proved to be true using operations and facts already known. A theorem is a major result. A minor one is called a lemma, L-E-M-M-A. So in this chapter, we learn how to explain the proof of a Pythagorean theorem and its converse. So a converse is a conditional statement. If this, then that, right? And made by swapping the if and then parts. If ... then. So an example of this is, if you are a dog, then you bark. The converse is, if you bark, then you are a dog. So we're going to use the converse to explain the Pythagorean theorem. How to apply the Pythagorean theorem to determine unknown side lengths and right triangles in real world and mathematical problems in 2 and 3 dimensions. So we're using this to determine also how to apply Pythagorean theorem to find the distance between 2 points in a coordinate system, so graphing. So in this chapter, we learn what is the Pythagorean theorem, what is the converse of the Pythagorean theorem, how can we use the Pythagorean theorem, and how can we use the Pythagorean theorem on the coordinate plane. So a right triangle is a triangle that has a right angle, so 90-degree angle, right? So Pythagoras discovered a very interesting thing about right triangles. And what he discovered was that any right triangle, the sum of its squares of the two legs, so we're going to see that in a second, the two legs of a triangle, which are the legs opposite the hypotenuse, the sum of the squares of those legs, the area, the squares of those legs, is equal to the square of the hypotenuse. And so we get the formula a squared plus b squared equals c squared. And then we end up with a bride's chair. And so we get what is called Pythagorean triples. So any 3 numbers, so 3, 4, 5, 3 squared plus 4 squared equals 5 squared, 5, 12, 13, 5 squared plus 12 squared equals 13 squared. And so these are Pythagorean triples. And so we learned that you can basically multiply that and end up with the same thing. So, you can double 3. 3 times 2 equals 6 squared plus 4 times 2, which is 8 squared. So 6 squared plus 8 squared equals 5 times 2, which is 10 squared. So 6, 8, 10 becomes the dilated version of that. So then what we do is the book gets into what is the converse of the Pythagorean theorem. So a converse is when you switch the front and back of the statement, right? So if a triangle is a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse. So we have a squared plus b squared equals c squared, where a is a leg and b is a leg. So you have the leg of a and the leg of b. And then these create the 90-degree angle. Then across from that is the hypotenuse. So here you have the Pythagorean triples formula, c squared equals a squared plus b squared. So if the sum of the squares of the legs, so as you can see, this is the square, the whole area on this side or this side of the triangle. these two squares equal this square, C. So basically all we're doing with the converse is switching. At the beginning, we're putting if the triangle is a right triangle. If, then the sum of the squares of the legs. And then we switch around and we say, if the squares of the legs, if the sum of the squares of the legs is equal to the square of the hypotenuse, then it's a right triangle. So if then, that's all we're switching. And this is called the bride's chair. Very big deal in masonry and stuff. In the mysteries, it's a very big deal. So then basically we use the Pythagorean theorem to find a missing side. So if B is missing, and we know what A is and we know what C is, then we can use A and C to find B. But that's if we know it's a right triangle. And we can use the commutative property, which protects the answer. And we can't switch the hypotenuse though, because they say that wouldn't work, right? Because a commutative property is the property of real, rational, and irrational numbers that states that the sum or products of two terms is affected by the order in which the terms are added or multiplied, is unaffected rather, by the order in which the terms are added or multiplied. So as you can see with a graph, we can use the Pythagorean theorem to find the angle of A to B, which is the hypotenuse. If we know there's a length of 3 between the side of A, and we know it's a length of 4 for the side of B, then A to B, which gives us C, can be found. And then, okay, and so then she goes into this chapter review here, and honestly, she rounds up in a couple of spots to the nearest tenth with the decimal places. Now, for this chapter, you're going to need to know about square roots and how to find them. I will link to one of the best videos, a couple of the best videos on how to do that in the description to this video, because it's tough to get them to the decimal place, because a lot of people are showing you how to just do it with the square root still, and they're working with decimals in this book. So you're going to want to know how to get to the nearest tenth in the decimal place with your square roots. And I found a guy who does that pretty well. It's a bit of a lengthy process, but at least then you understand how you're breaking this down using division in a bit of a different way. And the method definitely works because I used it and I got more accurate answers in the book. So, because like I said, she's rounding up and I was working out the exact decimal place. So yeah, that's about it. I mean, it's a pretty easy chapter. Not too much there to unpack. Pretty good introduction to the Pythagorean theorem. And so next will be chapter 16. We'll be going over probabilities. And there's only, I think, 18 chapters in the book, so should be fun.